To solve such type of questions, we need to rationalize them first. I'll explain this with the help of the first question. The first question is sin theta upon 1 minus cos theta is equals to cosec theta plus cot theta. Now we'll start with the LHS. Sin theta upon 1 minus cos theta. Now rationalizing means multiplying numerator and denominator by the denominator but with the opposite sign of the denominator. So here the denominator is having 1 minus cos theta, so we will multiply it by 1 plus cos theta. Now when we multiply, we will have sin theta into 1 plus cos theta upon 1 minus cos theta into 1 plus cos theta. Now we'll keep the numerator as it is. Now observe the denominator. In the denominator, we have the form of a minus b and a plus b. So that can be written as a square minus b square. So here we will get 1 minus cos square theta. Now we know that 1 minus cos square theta is sin theta. 1 minus cos square theta is sin square theta. So we'll just replace it in the denominator. So we will have sin theta 1 plus cos theta upon sin square theta. Now we will cancel this sin theta with this sin theta. So we will have 1 plus cos theta upon sin theta here. Only one sin theta is left, as one sin theta is cancelled by the sin theta in the numerator. Now after this we are going to separate the denominators. So when we separate the denominators, we'll have the same denominator. So 1 upon sin theta is equals to cos theta upon sin theta. Now we know that 1 upon sin theta is cosec theta. So cosec theta, and cos of theta upon sin theta is cot theta. So we have the RSUs here. Now again we are going to understand the same thing with the help of the second question. Here the second question is under the root 1 minus sin theta upon 1 plus cos theta is equals to sec theta minus tan theta. So in the LHS here, LHS is under the root 1 minus sin theta upon 1 plus sin theta. Now we have to rationalize it. I have told you that rationalizing means multiplying the numerator and denominator by the denominator with the opposite sign. So we'll multiply within the root, inside the root only. So 1 minus sin theta upon 1 plus sin theta. Our denominator is 1 plus sin theta, so we have to multiply it with the denominator but with opposite sign. So 1 minus sin theta, we are going to multiply by 1 minus sin theta inside the root, okay? Now, in the numerator, 1 minus sin theta into 1 minus sin theta is 1 minus sin theta whole square. And here in the denominator, 1 plus sin theta into 1 minus sin theta is again in the form of a plus b into a minus b, which can be written as a square minus b square. So here we can write it as 1 minus sin square theta. Now we know that 1 minus sin square theta is cos square theta. So we will replace the denominator by cos square theta. So we have 1 minus sin theta whole square upon cos square. I can write it like this, 1 minus sin theta upon cos theta whole square. Now when we will remove the square root, the square will be gone and we'll have 1 minus sin theta upon cos theta. Now again separating the denominator, we'll have 1 upon cos theta minus sin theta upon cos theta. 1 minus cos theta can be written as sec theta. Sin theta upon cos theta can be written as tan theta. Hence, we are getting the RHS here. And third question on the same pattern. Here, the question is sec theta minus tan theta upon sec theta plus tan theta is equals to 1 minus 2 sec theta tan theta plus 2 tan square theta. So again we are going to start with the LHS. So sec theta minus tan theta upon sec theta plus tan theta. Now we have to multiply the numerator and denominator by the denominator with the opposite sign. So we have sec theta minus tan theta upon sec theta minus tan theta. Now in the numerator it is a minus b into a minus b, so we will have sec theta minus tan theta whole square upon, in the numerator a plus b and a minus b form is there, so we can write it as a square minus b square. So we'll write it as sec square theta minus tan square theta. Now we know that tan square theta plus 1 is equals to sec square theta. So if I rearrange them, I can write it as sec square theta, taking tan square on that side, tan square theta is equals to 1. Now putting this value in this denominator, we will have sec theta minus tan theta upon, whole square upon sec square theta minus tan square theta is 1. So 1. Now here a minus b whole square. Applying the algebraic identity a minus b whole square, we will have sec square theta minus 2 sec theta tan theta plus tan square theta. Now I can write sec square theta as tan square theta plus 1. So I'll have tan square theta plus 1 minus 2 sec theta tan theta plus tan square theta. Now this tan square theta and this tan square theta becomes 2 tan square theta. So I'll have 1 minus 2 sec theta tan theta plus 2 tan square theta, which is our RHS.